Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss analyzing graphs of functions. Let's start by looking at the graph of a function and answering some questions about the graph. For example, suppose we wanted to find f of 0. So f of 0 is the y value when x is 0. So if you look at the graph, when x is 0, the y value is 2. F of 0 is equal to 2. What about f of 4? F of 4 would be the y value when x is 4. So if we look at the graph, you see the y value is 0. Same thing with f of negative 4. That would be the y value when x is negative 4. That would also be 0. How about the domain? So the domain is the set of all inputs. It's all the x values you can plug into your function that makes sense. However, all we know is that this is the graph of some function y equals f of x. We don't necessarily have a formula for it on the screen. So we have to use the graph to come up with the domain. To do that, what you do is you look at all the x values and you ask yourself, if I pick an x value, is it going to give me a y value? For example, if I pick an x value here at this red dot, I'm going to get a y value here. So this red dot on the x-axis is a number in my domain. Likewise, if I pick one here, I get a y value. So this red dot on the x-axis is a number in my domain. However, if I pick one over here on the right, there's no y value. So this red dot on the x-axis is a number that is not in my domain. The domain is all the x's you can pick that give you y values. So if you look here, the smallest x value is negative 4, and you include it because you actually get a y value there, you get 0. So the domain here, go back to blue, would be bracket negative 4 to 4. The domain is the set of all inputs, okay? It's all the x values that give rise to y values. The range is the set of all possible y values. In this case, the smallest y value is 0, and we include it, so we use a bracket. And the biggest one is 2, and we include it, so we use a bracket. So the domain is all the x values that lead to y values, and then the range is all the possible y values. All right, let's go ahead and do another example. Here we have another example of the graph of some function y equals f of x, and we're going to answer some other questions. So let's start by answering the question of where is the function increasing? So we're looking for the intervals on which the function is increasing. So to do this problem, you basically want to look at the graph from a left to right perspective. So if you're walking along the graph from left to right, you can see it's getting bigger here. Here it's going down, and then here it's going up. So thinking of it left to right. So from negative infinity all the way to negative 4, the y values are getting bigger. It'll be parentheses, negative infinity, negative 4, parentheses. You always want to use parentheses for increasing, decreasing. Always, no matter what, okay? So from negative infinity to negative 4, you see the y values are increasing. From negative 4 to 1, they're decreasing. That's not what we want. And then from 1 to infinity, the y values get big. So comma, 1 to infinity. You don't really want to put a union between these two sets because most of the times the question will say intervals on which the function is increasing. And if you put a union, it won't be an interval. So negative infinity to negative 4, getting bigger, so increasing. 1 to infinity, increasing. These are x values, okay? These are x values that you use to describe increasing. Let's do decreasing. I'll do it over here, decreasing. So again, you want to look at the graph from left to right. So getting bigger, 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 bigger. Oh, look, it's getting smaller. Starting at what x value? Negative 4. So it'll be negative 4 all the way. So over here, I'm sketching it in blue so you see it. Negative 4 to 1. That's where it's decreasing. I'm going to undo that. There we go. And that's it. It's not decreasing anywhere else, right? You might say, oh, it's decreasing on the left. That would be wrong because you have to look at it from a left to right perspective. You know, pretend a person is walking on the graph and they're walking up, so it's increasing. That's one way to think about it. If you're a little person and you're going up, you're increasing. If you're going down, you're decreasing. So left to right. All right, let's talk about something called a local maximum or a relative maximum. So the local or relative maximum So local max. A local max or relative max is the biggest y value relative to the points around it. So here at -4, 5, you see that 5 is bigger than the points around it. So 5 is a relative max. So it's actually 5. Okay. And it occurs at x equals -4. That's where it happens. If you like, you can describe the ordered pair. It would be -4, 5. You do have to pay special attention to the language when you're doing these problems about maximums. Some online homework systems will want the ordered pair. Some will want just the x coordinate. So if it's asking for the max, technically the answer is the y value. But if it says where does the max occur, you could answer with the ordered pair, or you could answer with x equals -4. But the point is that maximums and minimums are y values. The local max is the biggest y value relative to the points around it. Let's find the local min. The local min or relative min is the smallest y value relative to the points around it. So here you see -2 is the smallest y value relative to the points around it. So -2 is the local min, and it occurs at, you could write the ordered pair, 1, -2. That's where it actually occurs. So increasing left to right. So let me just show you one more time. I'll go back to blue. So the graph is increasing here from -infinity to -4, and also from 1 to infinity. So the blue area is here on the screen. That's where it's increasing. You see the y values get bigger wherever it's blue. So increasing. And then let's do red for decreasing. It's going to be here. And you can see these are the x values for which the y values are decreasing. And then 5 is the relative maximum because it's bigger than the points around it. Relative to the points around it, 5 is the biggest y value. And then -2 is the relative minimum because relative to the y values around it, it's the smallest y value. Sometimes people also call them local maximums. Kind of an interesting problem. I hope this video has been helpful. If you enjoyed this video, make sure to check out more videos on Chegg. Good luck.